Hi students, today we're going to be talking about taking the derivative of a quotient of functions. So we're going to use the quotient rule, and here's how it looks. So if we're taking the derivative of a function divided by another function, we need to use the quotient rule, and it will be the derivative of the function in the numerator or the function above the division bar times the function in the denominator minus the function in the numerator times the derivative of the function in the denominator divided by the denominator squared. Now, my calculus professor a long time ago used to call it this: low d high minus high d low divided by low squared. And again, low d high, low times the derivative of the high, minus the high times the derivative of the low, high d low, all of it divided by, let's get a different marker, all of this divided by the low squared. If that helps you remember it, great. You can always write it down or keep your paper with your formula for the quotient rule handy when you're doing homework. I would recommend that. Let's try this problem here, this example. So we want to take the derivative. So d dx, that's another way to say I'm taking the derivative with respect to x of this function. So notice that we have two pieces to this function. So 7x will be our f, and then x squared plus 4 will be our g, our lower function. F is our higher function, g is our lower function. Try not to get confused or concerned that this function is also called f. We can call it something else. For simplicity, actually, let's call it h of x. That way there's no confusion. You can notice this is a quotient of polynomials, and that's why, again, we have to use the quotient rule. So to take the derivative, h prime of x, we're going to take my low function, which is x squared plus 4, times the derivative with respect to x of the high function. So I'm going to write some intermediate steps here. d dx of 7x, okay, minus the high function f, which is 7x, times the derivative of the low function, the derivative of x squared plus 4. And I'm going to put that in parentheses just because I'm taking the derivative of both terms of that function. And then what are we dividing it all by? We're dividing by our low function squared. So our low function g squared, x squared plus 4, that whole quantity squared. All right? So let's go ahead and take another iteration of this. So h prime of x then is equal to x squared plus 4 times the derivative of, with respect to x of 7x, which is just 7, minus 7x times the derivative with respect to x of x squared plus 4, which will be 2x. And then we're going to divide this all by x squared plus 4, that quantity squared. Let's simplify a little bit and see if we can combine any like terms in the numerator. So h prime of x is equal to 7x squared plus 4 times 7, which is 28, because what we're doing is distributing that 7 to both terms. And then minus 7x times 2x, 14x squared, all over x squared plus 4 quantity squared. And then you notice that we have a couple of like terms here. We have 7x squared and we have negative 14x squared. So our final answer, h prime of x, is going to be 7 minus 14, which is negative 7x squared plus 28 divided by x squared plus 4 quantity squared. There's another way to express this answer. Let me put an or here. And let me write here, h prime of x is equal to, we can factor out that negative 7 and leave it as x squared minus 4 divided by x squared plus 4 quantity squared. So there's one answer. That one's fine. There's another answer. This one's correct as well, just a little bit more simplified. There's a third way to solve this and to show your answer. So let me show that up here too. And let's continue to draw our line around our work here. So h prime of x is equal to, if I were to factor my difference of squares, I would have negative 7 times x plus 2 times x minus 2 divided by x squared plus 4 quantity squared. Please notice there's no way to factor x squared plus 4. It's not a difference of squares, it's a sum of squares, and there's no factoring for that. So any of these three ways the answer could be shown. It's going to depend on your professor, what they are looking for. So continuing on with the problem that we were working before, let's determine when our derivative of our function h prime of x is equal to 0. When we're reaching either that peak, the slope of the tangent line is horizontal at a peak, or at a valley, the slope of that tangent line is equal to 0. So remember from last time, here was our function. We used the quotient rule to find the derivative and completely factored the numerator so that way we can work with it easier. So what do we want to do? We want to set h prime of x equal to 0. So 0 equals negative 7 times x plus 2 times x minus 2 divided by x squared plus 4 quantity squared. So how will we solve this? Well, we'll want to multiply both sides by that denominator, x squared plus 4 quantity squared on the right side here, and also on the left side. Now notice when you multiply anything by 0, you still are left with 0. So we'll have here that 0 equals just the numerator, because the numerator, what we multiplied by x squared plus 4 squared divided by x squared plus 4 squared, that just leaves 1. So it's 1 times our numerator. So negative 7 times x plus 2 times x minus 2. Since this is factored already, all we have to do is use the zero factor property. If you know that any things that are multiplied together equal 0, then at least one of these things is 0. Now negative 7 can never be 0, it's just negative 7. So what we want to do here is we want to look at the factors of our binomials here. We want to set each of these equal to 0. X plus 2 equal to 0 and solve that. So therefore x equals negative 2 and x minus 2 equals 0. Adding 2 to both sides, we have that x is equal to positive 2. So there's two values of x where this function is going to be either a peak or a valley, and we don't know which from this. We haven't done enough work. We would need to investigate the derivative before and after, or in between even these x values, to determine the sign of the derivative. That would tell us if the function was increasing or if it was decreasing. It's got to be one of those two in between these values of x. So if I were to replace x equals -2 in the original equation, I would find the y value, or the h of x value that corresponds with this. I would find the ordered pair where we have a peak or a valley. So let's do that. So if x is -2, I'm going to evaluate h of -2, which is 7 times -2, divided by -2 quantity squared plus 4. This will be -14 divided by 4 plus 4, which is 8. I can calculate and simplify that h of -2 is going to be -7 over 4. So I have an ordered pair, -2, -7 over 4, is either a peak or a valley in this function. Let's do the same thing here for x is equal to +2. So we'll calculate h of 2. Again, replacing x in the original equation, because we're looking for a point, an ordered pair on the original graph, not the derivative. So 7 times 2 divided by 2 squared plus 4. So we'll have 14 over 4. So h of 2 is 7 over 2. Sorry, 14 over 8. Let's fix that up. My boo-boo. So our answer is 7 over 4. So we have an ordered pair at x equals 2. The height is 7/4. Hi students, let's take the derivative of this function. F of x equals 5x to the 5th plus 6x to the 4th plus 5x cubed divided by x to the 4th. So we could use the quotient rule. There would be nothing wrong with using it. But when there's an easier way to simplify a function before you do any kind of derivative, calculate any derivative, you definitely want to do that. I can see that I have a monomial in the denominator. I can take and break up this function so it's just a sequence of sums of fractions. So let's rewrite it like this. I can divide each term, 5x to the 5th, for example, divided by x to the 4th. And then add it to the fraction or the quotient, 6x to the 4th divided by x to the 4th. And similarly, my last term here, 5x cubed, I can divide it by x to the 4th. So let's simplify this and then see what kind of method we will use to find the derivative. I prefer to simplify up front because, you know, this quotient rule has a lot of steps to it. The more steps a procedure or process has, the more opportunities to make an error. So the simpler the better when it comes to any kind of mathematics procedure. Try to see simplifying up front is the way to go if you can do that. So now what I have when I divide out this x to the 4th, I have x to the 5th divided by x to the 4th. That will leave me an x in the first, above the division bar, x to the 1st, plus just 6 because x to the 4th divided by x to the 4th is just 1. And then I'll have plus 5, and then notice I have x cubed above the division bar, but x to the 4th below the division bar. It's like I have x times x times x, x cubed, divided by x times x times x times x, x to the 4th. So every x divided by x is equal to 1. Every x divided by x is equal to 1. And notice what's left, a 1 above the division bar times 5, which would be 5, divided by x. So let's rewrite this in a little bit more convenient form, because what are we doing with this polynomial? We are finding the derivative. So it's just the last term I need to simplify. And let's call it 5x to the minus 1, because it will be easier for me to take the derivative of a term that looks like this. All right, so now let's take the derivative. So the derivative of 5x is 5. The derivative of 5x to the minus 1 will be minus 5x to the minus 2. So to finish this problem off, the first derivative of this function then is 5. And I can factor out the 5 if I'd like. Minus 5 over x squared. I could also call it f prime of x is equal to 5, 1 minus 1 over x squared. There's a few other ways to show this. Again, it's going to depend on what your professor expects for simplified answers. Let's do another example of using the quotient rule. So we want to find the derivative of f of x equals 4 minus x squared divided by 7 plus x squared. Now, just a reminder, we cannot remove, or as you would probably say, cancel out those x squared terms. The only time we can remove factors from the numerator and the denominator here is if we are able to factor them out from both terms. Notice that the 4 does not have any x factors associated with it. Neither does the 7. Therefore, we cannot remove these x squared. We're stuck with them. Let's go ahead and take the derivative using our quotient rule. So f prime of x then will be, so we're going to take the derivative, we're going to take the low function, 7 plus x squared, times the derivative of the high. So the derivative of 4 minus x squared would be negative 2x, okay, minus the high, so 4 minus x squared, times the derivative of the low. So the derivative of 7 plus x squared will be 2x. And then all of that divided by the low squared. 7 plus x squared, the whole quantity squared. Before we continue, just to note, that I have it written in a couple of different ways, this quotient rule. F prime times g is the same thing as g times f prime. Multiplication's commutative. We can multiply in either order. It doesn't matter the order. We get the same answer. When we're multiplying numbers, 3 times 4 is the same thing as 4 times 3. All right? So that's why you can choose to follow it right here with the little saying to help you remember it, or you can use what is in our textbook. Either works. Let's go ahead and simplify. So we need to distribute this negative 2x to both terms, and in the second part of this numerator, we need to distribute that positive 2x to both terms, keeping in mind that we have a subtraction here. So that negative sign is going to have to be distributed. But let's take it step by step. So f prime of x is equal to, so 7 times negative 2x, negative 14x, and then x squared times negative 2x minus 2x cubed, or to the third power, minus, and let's for now just put this in brackets so that way I remember that I am subtracting as ever many terms there will be, which will be 2 terms, when I distribute this 2x following that subtraction. So 4 times 2x is 8x, and then negative x squared times 2x is minus 2x cubed. And again, I'm just putting those brackets there temporarily to remind me that I need to distribute that subtraction. We're subtracting both terms, not just the first one. So let's write it out in a little bit more simpler form. So negative 14x minus 2x cubed, and then it will be minus 8x, and then it'll be plus 2x cubed, divided by that denominator, 7 plus x squared, quantity squared. If you notice, we have a minus 2x cubed here and a positive 2x cubed. Those are going to be gone. And we can simplify because we have like terms here. We have a negative 14x minus 8x. So our first derivative, negative 22x, it's like you have, and I know this doesn't make a lot of sense, but bear with me here. Negative 14 apples, and you have minus 8 apples. You would have, or you gave 14 apples away, and then you gave another 8 apples away. How many apples did you give away? 22 apples. So that maybe that makes sense. And then divided by 7 plus x squared, quantity squared. And that's our final answer. It can't be simplified any further. Hope this helps, students. Bye.